So hello everyone, I welcome you in my class once again. So in last class we have seen the introductory part of 6th degree of freedom, where we have started with a very simple example, pitching moment equation, and we have derived the transfer function. We have drawn the closed loop for a pitch loop, control loop for a pitch loop also. So in this class we will study in detail what do you mean by aircraft model and what do you mean by aircraft dynamics. So first we need to understand frame of reference, because frame of reference is what? Reference is what? Some kind of observer, right? For example, if you are moving with some velocity, if I am stationary, I can tell you are moving at what velocity? 5 meter per second, 10 meter per second. Also, if you are moving with some velocity and I am moving with the constant velocity, that also I can tell you at what velocity you are moving. So that is why inertial frame is required, where the actually when the acceleration is 0, then only you can measure the quantity. So that is why Newton's law is applicable in an inertial frame. So inertial frame you can draw on a earth also. You can take north, east and down. Let's say this is north, this is east and this one is a down. Now, but since our concern is aircraft, right? So aircraft is moving, translating and orienting, okay, translating in 3 direction, orienting in 3 direction. That means one frame definitely we have to fix on a body. So that frame is known as a body frame, where x axis is this fuselage reference line are perpendicular to this y axis, and both perpendicular to x and y there is a z axis according to the right hand rule, like this. So this frame is okay, this frame is okay, purpose is also I have told you, and the next two frame is stability frame and wind frame. So we know that when the velocity vector makes with the angle alpha with the fuselage reference line for a complete aircraft case, that known as angle of attack. So if the wind is coming from that direction or relative air is coming from that direction, so that means what? This frame will be the x, perpendicular to that will be y, and z will be perpendicular to both x and y. So that will be the stability frame, and when you rotate stability frame by the side slip angle beta, then you will reach to the wind frame, right? Again I am repeating it to you. Body frame already I told you. So when you have an angle alpha with the fuselage reference line, okay, and if you take a x axis along to this line and perpendicular to this axis there will be two line other, so that will be known as a stability frame. And when you take wind from any arbitrary direction, and if you this consider as a x axis, that will be known as a wind frame. If you want to go back from wind to body, then what you will do, you will rotate by beta and then alpha. So that is the definition of stability and wind frame. But in today class we will be focusing on inertial frame and body frame. Body frame, that means body is actually moving, so I have to measure each and every quantity in inertial frame, forces and moment. So I will transform my quantity from body frame to inertial frame, right? So for that I will perform 3 to 1 rotation. Do not confuse with what do you mean by 3 to 1, each and everything I will told to you in this class. So for example, let's say this is a what you can say, this is a inertial frame. This is a one axis you draw. This will be the, according to the right hand rule, this will be your inertial frame, x, y and z, right? So how the body axis is different from this axis? Only by 3 rotation, right? For example, pitch, roll and yaw, max to max 3 angle the aircraft can perform. So that means I can generalize my rotation and I can comment on that. If I rotate my aircraft by angle, let's say psi, and then theta and then phi, then I will reach to the body frame, right? So because you can, the inertial axis and body axis can differ in this way only, right? Only three angle we have, right? Or you can rotate phi, theta and psi to reach from body to inertial. So what angle we will perform? Psi, theta, phi. Three consecutive rotation we have to perform. So that is why it's called 3211. Tell you what is 3211. And in this lecture also we will try to stabilize the relation between body rates and Euler rates. So again the question is, what do you mean by body rates and what do you mean by Euler rates? So the body rate is, this is axis rested, right? So rotating here, rotating, right? This is pitch, this is Z, right? So in body axis there is a three axis, right? So about which what is the rotation? PQR. P about X, Q about Y and R about Z. So PQR is a body rate. Similarly, when you are giving the rotation psi, that means there is angle psi, then theta, there is angle theta, and then phi, there is angle phi. So if you take the derivative, phi dot, theta dot, psi dot, so phi, theta, psi, it's called Euler angle, and phi dot, theta dot, psi dot is the Euler rates. So this is also rate, this is also rates. So there is a difference, right? Because you are not directly jumping from inertial to body or body to inertial. There is an intermediate frame is involved. What frame? Theta is there in the intermediate frame, right? Okay. So when you rotate some angle psi and theta, some angle, and then phi. So what is the final frame? An inertial frame. In between you have a two more frame, right? Let's say this one. You got new frame, right? You got new frame, right? And finally you got body. So intermediate frame is called vehicle frame 1 and vehicle frame 2. So this is very, very important, because I say observer, you will be in the ground and you will be monitoring the aircraft, how the aircraft is flying. So now this part is clear, right? Now in aircraft model and dynamics, now in today's class we will complete the 6 degree of freedom. Complete 6 degree of freedom. What are the forces and moment acting on the aircraft? In forces and moment, we will study a gravitational force, aerodynamic force, propulsive force, and then what do I mean by aerodynamic model, and finally equations of motion in a body axis, and then we will write in a compact form of dynamics. So we go one by one. So now this is a diagram. You can see this is the aircraft. Okay, whatever axis we are take a start, we will take from the CG. So this is the x-axis perpendicular to y, and there will be the z downward direction, and this is the inertial frame, right? And if you rotate the body axis by the alpha, you will reach the stability frame. This is by alpha, and when you rotate from alpha to beta, you will finally reach from the wind frame. So all the frame is clear to you, and this is the transformation rotation matrix we will find out. 3 to 1, right? Phi theta psi. No, 3 to 1 rotation. So now this 3-2 rotation I have performed. You can see this, but I will tell you how to obtain this matrix, because it is very important that how we have obtained this. How we obtain this, for example. Let's say first matrix how we obtain. You always have a one model with you, so that you will be able to visualize easily. Let's say my first rotation is psi, right? So I will mark this fuselage axis along this x axis. This is a x, and perpendicular to that I will draw y, and then finally z, right? Now I will rotate. So I can reach to the x1 by angle what? Psi. And when I am rotating this, the y is also coming towards me, right? That means this. Okay, right? And what rotation you have performed? This way, right? So I will take, that is the axis, but this remains the same, right? This axis is z axis is not changing, right? Now I want the component this x1 and x2 on a x and y. So what I can do? I can draw one horizontal line. I can draw one vertical line. And please tell me what is the component x1 along this x? What is this? x1 cos psi. Perfect, right? And what about this? Perfect, right? And what about this? y1 cos psi. And along this y1. Now so I can write here, see, I can write here x equal to what? X equal to, I can write x1 cos psi minus y1 sin psi, right? And what about y? Y, how I can write? x1 plus y1 cos. Okay, so now I can add, see, I can add 0x1, 0 y1 and 0 z1, and here I can write 0 z1 and here I can write 0 z1. So in matrix one, what I can write? X, y, z will be what? What I can write? Cos psi minus sin psi, sin psi, cos psi, 0 0 1 0 0. So that means the axis which you are rotating does not have any component, only unity component, and remaining the along this side, along that side is 0, and whatever you are having change in only x and y. There is a no change in z, and one decide that's the about z axis you are performing the rotation. And how this minus sign is coming, that also. And this is a very important property. If you take the determinant, it will be only 1, because as a vector you are rotating, you are not increasing or decreasing, right? So obviously from the mathematical perspective the determinant will be 1, and that is same I have written here. You can see how I written c psi, that means cos psi, minus sin psi 0, sin psi cos psi 0 0 0 1, right? So always take a model in your hand and try to rotate the aircraft, then only you will not be able to confuse which axis I am going, what angle I am rotating, and what rate I am rotating, right? So this matrix you have found out. Similarly, the second rotation we will perform about theta, it will be the pitch axis. So this matrix you will write, and finally will you take a roll and you will take this, and if you multiply by all this, you finally reach to this rotation matrix. That means you can transform from body to inertial. And why from body to inertial, not inertial from body? That also you can see from here easily, because you should not have any confusion. What you will write here? X1 y1 z1, and when you go from x1 y1 z1 to x2 y2 z2, you will put the expression, and there here you will get the theta matrix. And then finally when you put x2 y2 z2 to final body axis, then you will write here phi matrix. So if you multiply, you will get like this, right? So this is the first rotation, second rotation, and third rotation. So 3 2 1. Now so see this part UVW is a body axis velocity, that means body axis, but we are measuring where? In inertial. Okay, so that is the importance of rotation matrix. So see how the rotation matrix is important. If you take theta is 90 degree and there is a no roll, so what you are going? You are going in a this direction, and according to inertial, this is what? Minus z axis. So actually you are moving in a body axis, but when you see from the inertial frame, you are moving along what? Minus z axis. So that is the importance of rotation matrix. You can actually, you cannot measure the position and in a body frame. The moment you will measure, the things will change. So that is why the quantity you have to take the transform from body to inertial. That is the importance. Because in inertial frame you can apply the Newton's law. So rotation matrix is clear, right? So now I have stabilized the relation between inertial to body to inertial, right? Now when you are performing the rotation, you are actually what? You are rotating by z axis, and then first rotation about what? That is about z axis. So that means what angle you are rotating psi, and what is the rate is psi dot. So this is psi dot, and this one is a theta dot, and this one is a phi dot. But for example, I clearly told you that there is a two intermediate frame is involved between inertia to body. So that means short PQR will not be equal to phi dot theta dot psi dot. I'm repeating here. Phi dot theta dot psi dot will not be equal to P, Q and R because two intermediate frame is involved. So in order to stabilize the relation between phi dot theta dot and psi dot and PQR, what you can think, you can take from the psi dot, since you have not given any rotation, that means phi dot and theta dot. So what is the rotation matrix? You will write theta rotation matrix and phi rotation matrix. And once you done with this, then what are the other rotation matrix you have? Let's say for example, you have a theta dot. So to reach from theta dot to phi dot, what is the rotation matrix? Phi, right? You have written phi, and finally when you reach phi dot, you can directly write phi dot 0 0. If you sum up, then you can actually get this matrix, and if you take the inverse, you will get this matrix. Okay, so now clearly you can see what is the relation between phi dot theta dot psi dot and PQR, but you have to be very careful here. You can see the cos theta term, and cos 90 is what? 0. So 1 by 0 is infinite, so there will be the singularity. So when you give 3 to 1 rotation, and for example let's say psi, theta and phi, so singularity will come in between, that means theta plus minus 90. From the mathematics also you can see here, and more importantly physically you can actually have a feel. Let's say you have an aircraft in your hand, you can draw one imaginary circle, one pointing this, okay, and another pointing this axis, okay. So this is a one circle, and this is a one circle, and what about the third circle? This circle, right? So now when you take a pitch up, then two ring will lock right together. So actually you cannot define a roll. Can you define roll here? Here you can define roll, but when you do the aircraft like this, you cannot define the roll, right? So that is a problem. So that is known as a singularity. Okay. So in order to deal with, generally people use the quaternion. So that is a separate topic. Now so far what we have discussed is kinematics. There is a no force involvement at all. Now from this slide we will try to cover the kinetics part, where you will see what kind of forces acting on aircraft and how it is influencing to the aircraft, right? So what are the forces acting on the aircraft? Can anybody tell? Three forces, right? Aerodynamic forces, gravitational forces and propulsion. So it is very first we will understand the gravity force. So let's say we have a model in our hand. So gravity will always act on a downward direction. Okay. So let's say you have rotated some angle theta. So what will be the component along x-axis? See, I want each and every force, whether it is aerodynamic force, gravitational force or propulsion force on a body frame. So all the force I will resolve on the body frame. Then I will sum up, I will apply the Newton law. Okay. Now, when you do this, so there is a two component, right? Along the x-axis there will be mg sin theta, and along the z there will be mg cos theta. For example, let's say easily we can visualize here. Let's say this is the aircraft, the weight is acting downward, right? Now when you rotate, so this is the when you rotate the when you do some kind of pitch up like this, so your stability axis will be this direction, right? Body axis. So this will be the mg cos theta, and what will be this? Mg sin theta. You can understand in this way. Okay. So I want all the forces in stability axis, right? This is the x-axis. Sorry, body reference frame, right? If you go back to the PPT, you can see mg sin theta I have written here. Mg sin theta, because it is a negative direction mg sin theta, and that is why I have written. Forget about the phi. When you put phi equal to 0, you are getting mg sin theta. I already explained to you. And what is the z component? Mg cos theta, right? When you do the pitch, z axis is rotated by y, mg cos theta. So that is why, and when you rotate this, when you take a phi, then mg cos theta will have a two component, one along the y and one along the final z. So that is nothing but the mg cos theta. It is present here in both the things, and there will be one sine component and there will be the one cos component. Now we will have a aerodynamic force, and now the gravitational force is clear to you guys, right? Now in aerodynamic forces, what is aerodynamic forces? We will have aerodynamic force in x direction, y direction and z direction. When I say x, y, z, that means body. Here I will talk about only body axis, because for example, when you are not talking about the body axis, then gravitational force you can write directly mg. But since you are giving the rotation, and you can see one more interesting fact, you can see whatever you rotate, you will psi does not matter all in the gravity. That is why you can see psi component is not coming here, because whether you will rotate this direction, that direction, irrespective, weight is weight, active will downward, right? So it depends upon two rotations, theta and phi, not the psi. Physically you can have a feel. Now again, the second force is aerodynamic force. Here also we will talk about the body axis. So fx, fy, fz, body axis force. Now you can see q. Q you can define as a this quantity, by this quantity. Q perfect, Q equal to half rho v square. V is a flight velocity, rho is a density, half rho square total is a dynamic pressure. S is a wing area. S is a wing area. Cy is a side force coefficient. Cl is a lift coefficient. Cd is a drag coefficient. Alpha is angle of attack. Q is pitch rate. L delta is elevator deflection. Similarly, beta is side slip angle. P is roll rate. R is yaw rate. Delta is elevator. Delta is aileron. Delta R is a rudder. Right? So again you can see I can write half rho square S. Then why this CD and CL is coming? Because CL and CD are in the stability frame. So we have to get back to the body frame. For example, like I can write half rho v square S into CX simply Fx. So this part is Q bar, this part S, and what is the CX is written? CX is this part. So how you can easily have a feel. For example, let's say this is your stability axis, sorry, body axis. Now you will take a free stream velocity. This is making alpha, right? So there will be the lift and there is a drag. If I will non-dimensional, I will write put C, CL and CD. This is alpha, so this is also alpha. So I want to resolve my component in this direction. So you can see CD cos alpha, and along this if you resolve, then what will be the component? CL cos alpha, and this one is a CL sin alpha. So you can see CL sin alpha minus CD cos alpha. S alpha means sin alpha. So you can see along this is a positive, that is why this is a positive sign CL sin alpha, and along this is a negative, that is why I have written minus CD sin alpha. Similarly, in a Z component, you will have a minus CD sin alpha and minus CL cos alpha. So there is a no doubt about the aerodynamic forces, right? Because you have to understand why I have written this minus sign plus sign sin alpha cos alpha. Because earlier it was in the stability frame, but I have transformed in the body frame because my interest is in I have to have a force on a body frame, and then finally what I will do, I will take the transformation I said to you by the rotation of material, and I will get the information in inertial frame. That's the whole purpose, right? So this is the Fx. Similarly, Fy is a half rho square Cy, and there is a no problem in Cy because there is a no wind frame is involved, no wind I have taken, so Cy directly you can write. And similarly, when you take a Z component, what you will take the Z component? CD. So this is the CD cos alpha, this will be the CD sin alpha, right? CD sin alpha, and so CD sin alpha plus CL cos alpha, but both the sign is negative, right? Why? Because I have considered downward Z as a positive, but this force is going upward, so that is why I have multiplied by the minus in both the sides. Clear to you guys, right? So now gravitational force and aerodynamic force are clear. So what is the next force? Propulsive force, right? So propulsive force, I am considering only along the S direction. I am mounting in engine in a such way that it is passes through the body x-axis. There is a no component in y and there is a no component in a z, and simply I am modeling as a T max into delta E. That means maximum engine thrust which is producing, I can model as a delta T, where there I can put 60%, 0.6, that means 60% I am using. If I put delta T 0.7, that means 70% I am using. So this delta T is nothing but a throttle setting. You can see there is a cockpit, right? You can put the throttle 0 to 1. So 1 means utilizing maximum, right? And since I already said to you, I am not considering the thrust along the y and z, and so that is why the component I have written 0. But in real case it can come. For example, if you have a twin engine, the y component sure shot will come. Okay. Now this all about the forces, and similarly the aerodynamic moment you can write. So aerodynamic moment is half rho square s. CL CM CN is nothing but the rolling moment coefficient, pitching moment coefficient, and yawing moment coefficient. As I said, there is a force, right? So in force what you have a CLCD, force coefficient. Similarly in a moment you have a moment coefficient. So CL CM CN is a moment coefficient. In roll, pitch and yaw, Q already I told you half rho square, S is a wing area, B is a wing span, C is a wing chord, and these moments are the function of beta P R delta A delta R. Similarly alpha Q delta E and beta P R delta A delta R. So we have to understand what do you mean by this. So in this slide, what I will show you, this is the aerodynamic model you can write, where you can write CL equal to CL naught plus CL alpha into alpha plus CL Q into QC by 2V plus CL delta into delta E. Similarly, all the coefficient you can write as a in a linear form with dependent to different derivative like pitch derivative, damping derivative, control derivative. So the each and every parameter significance value we have derived in the aircraft design course. You can go back and you can have a feel for this parameter. Okay. So now it is clear to you guys. Now Like for example, this is a Cm alpha, which is a stability derivative in pitch. Similarly, you will have a Cl beta in roll and Cn beta in yaw. And the damping derivative Cmq in pitch, you have a damping derivative Clp in roll and Cnp in a yaw. Okay, you can go back to the aircraft design course and you can have a feel for aerodynamic model, derivatives, coefficient and everything. Okay. Now, when you do everything, okay, so you can write actually 6 degree of freedom. So do not worry about this. You forget about this first translation and rotational dynamics. You just focus on, we have derived this path, right? X dot, y dot, z dot. If you take element, you can find out the rotation matrix, right? So this part and this part is derived, right? Because already we have stabilized phi dot, theta dot, psi dot relation to PQR and x dot, y dot, z dot to UVW by the rotation matrix. See, if you multiply by the minus sign, z dot will become h dot, because this is z dot, this is h dot, right? Simple. But when you go to the dynamics part, u dot, v dot, w dot, p dot, q dot, r dot represents the 6 degree of freedom. You can translate in this direction, this direction, this direction, u dot, v dot, w dot, and rotate in 3 direction, this and this. So p dot, q dot, r dot. But see, when you can obtain this by putting f equal to ma, right? But the thing is, f equal to ma you can put in an inertial frame, right? So that means somehow I have to find out the forces, all the external forces. That is why I told you that gravitational force, aerodynamic force, propulsive force. You see this gravitational force g sin theta added, aerodynamic force added, propulsive force added. But how this gentleman is coming? Rv minus Qw. You write F equal to ma. That means F equal to mv dot. In x direction, I can write Fx equal to mu dot. If you divide by F, you will get u dot equal to Fx by m. That is why you will get by m. This is mg, mm will get cancelled. Everything you will get. But how this Rv minus Qw gentleman is coming? So we have to understand this part. This is a very tricky part. Please pay attention to here. This will be helpful for in moment case also. So let's say you have any vector r. This is I, yj and zk. And consider this r is a vector. You can put a vector depending upon your choice. Now you take a derivative. You take a derivative r dot. You will write x dot I, y dot j, z dot k, and according to the derivative rule, you have to take x constant and you have to take a derivative of I, right? Because differentiation of u is what? U dot v plus v dot u, right? So that means you can write j dot and then you can write zk dot. Now you can write this as a d by dt xi yj and zk, and this you can write I, you can write what? I dot omega cross I. This you can write omega take, you can take common, cross you can take common, and in bracket you will have a xi yj and zk. You do not take a point inside, otherwise you will confuse with the dot. So I can write here r dot is dr by dt plus omega cross r. So this will be in an inertial frame. this will be the body, and this due to the rotation. So that is how you can transform from the body to inertia. Now take this. Okay, please note down. See why, how it is derived, I have told you. Now you please consider this d by dt. Now we have arrived this point d by dt body plus omega cross something, right? So you will put v, you will put v, you will put v. So now find out omega cross v. So omega is, you can write I j k. I am writing omega cross v. You can write p q r, and v you can write u v w. Are you familiar with how to find omega cross a in math? Omega is cross a, that means determinant of this. So what you can write? I q w minus v r, right? R v, and plus j cap, you can write ru minus pw, and then k cap you can write pv minus uq, pv minus uq. Okay, now if you multiply by m here, then this you can call as a force, right? So this the total force you can write fx I cap, fy j cap, and fz k cap, and here you can write mu dot mv dot, this is I cap, j cap, and mw dot k cap, and you can take a sum here, this part multiply by m everywhere. So if you compare fx, what you will get? Compare fx, what you will get? Mu dot, please pay attention here, mu dot plus, what should I write? Mu dot plus, I am comparing I, right? What should I write here? M qw minus rv, right? So what is my u dot? Can anybody tell me u dot? U dot is rv minus qw plus fx by m, right? So now you can see rv minus qw, right, and fx by m. So go back to here, rv minus qw, and fx by m is what? This, right? So that is why this gentleman is coming rv minus. Similarly in v, this will be, you have a pw minus rv ru, and in w dot you have a qu minus pv. So this force equation is clear, right? This is also clear, this is also clear. Now we will hit this p dot q dot and r dot part. Okay, so that is my, this contribution is coming because you are taking the, you are going back to the inertial from the body frame. So because of the rotation there is a difference. So how you have done this, I have explained to you by simple taking a vector and taking a derivative, simple, right? And now we will go back to this rotational dynamics part, and we'll try to stabilize this relation, because three things is clear to you. This part, this part, this part, aerodynamic moment part, it is clear to you. But how this part is coming, this part, and how this gamma is coming, that will be clear to you. Okay. So you might have studied the moment is rate of change of angular momentum. The force is rate of change of linear momentum, and the moment is rate of change of angular momentum. And now here my interest is what? Find out the moment. So this will have a roll, pitch and yaw moment. So first we have to find out the angular momentum, right? So angular momentum is what? Angular momentum generally you write r cross omega cross r, right? You have this, right? R cross omega, you have this, right? And if you multiply by small delta m, you have a elemental angular momentum. Okay. In next step, what you will do? Next step you will do dh by dt inertial frame into dh by dt body frame and then omega cross h. Omega cross h, right? So this, when you take a, for example, when you take this part, I can easily write here. You have written what? Fx, Fy and Fz. What you have written? Mu dot plus M Qw minus Rv and Fy Mv dot plus M Ru minus Pw. Perfect. And this Mw dot Pv minus Qu. Easy to remember. See, when you write S, there is a no U component, right? And there is a no P component. So Qw minus Rv. You can easily find. Now, I was here, right? I was here. Please note that I was here. dh by dt inertial, dh by dt body and omega cross h, right? So what about the moment about x-axis, right? We have written three forces, right? Fx, Fy, Fz. Similarly, I will write three moment L, M, N. So what you can write? L. Directly by seeing this only you can write L. No need to again do the mathematics. You can write Hx dot plus what is Q? This is the Z direction, right? So I will write Hz minus R Hy, and similarly you will write M as a Hy dot, and this is R, this is U, that means Hx, and this is what? P, and this is Hz, and similarly yawing moment L, you will write Hz dot, and plus what is P? P is F, and this is Q, Hx. So when I have a this axis, x axis, there is a no x component, only z and y is there. When I am taking y axis, there is a x and z component is there, and when I am taking n yawing axis, there is only x and y is present. Okay. So by seeing this, you have written this. Okay. Now this hx, hy dot. So hx is dot what? Hx dot is p dot into ixx, and hy dot is q dot into iyy, and hz dot is r dot into izz. Now go back to my previous class. What I have written? Simply m equal to iyy q dot. So iyy q dot I have written. Okay. Equal to pitching moment. That means this term I have neglected. RHX minus PHZ. That means I was not considering any other moment that time. So that is why simply I have written Q dot Iyy equal to pitching moment, half rho square S into Cm. But here When you take all complete 6 degree of freedom, you cannot do this. So now you have P dot Q dot R dot. So P dot Q dot R dot will be sitting here, and find out the Hx, Hy and Hz, right? And you substitute this, you will get rearrange this, because see, 3 equation, right? So take P dot Q dot R dot in a one direction, remaining the other direction, remaining is what? Lmn, and this part. So you will have a this P dot Q dot and R dot equation. Remember that when you are dealing with the linear motion, you have a mass, but when you are dealing with a rotational motion, you having a inertia. So this is the complete 6 degree of freedom, where you can see I have derived u dot v dot w dot. That means translation is in a 3 direction, acceleration in a 3 direction, and then P dot Q dot R dot, that represent the rotational motion. So 3 plus 3 complete 6 degree. So 3 translation and 3 rotation, 6 degree of freedom, right? These are called kinetics equation, or in another sense is called dynamic equation, that represent the aircraft equations of motion. But since we have to take the information from the body, because actually body is moving, and as an observer we have to sit in the inertial frame and we have to measure every quantity. That is why we have done the rotation 3-2-1-1 rotation, and that is this part. And when you rotate with the some angle, for example, like when you go from the body to inertial, you can rotate with some rate, phi dot, theta dot, psi dot. So that means you can stabilize the relation between body rates and Euler rates, phi dot, theta dot, psi dot, and PQR. So that is I have given to you. The purpose of this giving to you to understand the significance of the singularity. What is singularity? I told that ki, you imagine this is aircraft, you take 3 circles, one circle is this, one circle is this, and one circle is this. Imagine when you are taking pitch up, this 2 ring will lock together and you cannot define the role. That is called gimbal lock, and mathematically it is the singularity. Okay. So in next class, what I will do, I will write all those equations in MATLAB Simulink, and I will try to give you the feel for each and every parameter, how the aerodynamic model plays the significant role to fly the aircraft beautifully or badly, or rest of the parameter also, how it will affect the in aircraft equation of motion. So thank you very much.